Is everybody on?
Mm,
Because they're using it on yet.
I guess doing it anyway.
hey guys.
Hey,
How's it going?
Good. Just gave my son a bath. That was a wrestling match.
who won?
Huh?
Who won?
Well, he had a circumcision last week,
Oh,
so it hurts to go to the bathroom or taking a bath. So
That's fun.
I guess you could say that.
are we good to go now?
Yeah, we're good to go. We're live, so we can start the quiz whenever you guys are ready.
Okay. I could read the first one.
Okay.
First one to until those ready. You did it. So we got all this data right here. And let me read it all down. The first question for number 3 is, what is the value of a statistic? Is someone, are you guys getting that back?
Yeah, I can't hear.
What are you saying? I couldn't hear you.
Can you guys hear me?
Yeah, I can hear you, but some static is going on.
I'm not static.
There we go.
Where the static? Okay.
I think it sounds better now.
What?
It sounds better now.
Yeah. Okay. What is the value of the test statistic? So, let's see. The test statistically.
I got 2 on that one.
2?
How did you get that?
So what you do is you take the C, which is 2.2, you subtract that from the population mean, which is the null hypothesis, which is 0.
There.
So you do 2.2 minus 0, and then you divide it by the sample standard deviation, which is that 3.3, which is then divided by the square root of the sample size. So I did 2.2 minus 0 divided by 3.3 divided by the square root of that, which is 3. So it comes out to 2. But I'm pretty sure that's what it is, but let me know if you guys do something.
And that is the formula correctly.
What did you say?
Yeah, that's the formula. I was just looking at it just barely.
Okay. So.
Like I was just looking at the formula for this. Does everyone agree on that though?
Yeah.
Okay, I'll read question 4 then. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. So I used the normal probability applet for this, and from what it looks like, what you find. So it says that the p-value is the area to the left of t under the curve. So from what I understand, that means that you type in 2 into the normal probability applet, and then you highlight everything on the left of the 2 marker. So I got 0.9772, but do you guys think it's something else than that?
You got 0.0772?
Yeah.
Okay. We'll need to round it to the place, so that would be 0.098.
Yeah, I think it'd be 0.0980. Is that right?
It's supposed to be 3 decimal. Yeah.
Yeah, so wouldn't it still be 0.977 then if it's 2 decimal places?
Did you get 0.098 or 0.0977, or did you get?
I got 0.0 or 0.9772.
It would be 0.977.
Yeah.
You got it to 3 decimal places.
That's what I thought too.
That's right. Does anyone get a different answer?
You said 0.998?
0.977.
Okay. Sorry, the static is really...
Yeah.
Is it really staticky on mine?
Yeah. I mean, yours sounds alright, but I don't know.
I don't know. It's just coming from somebody.
Well,
It
it
sounds
went
better.
away. Yeah, it sounds better.
Whose is it? It's not mine. It's not yours.
I haven't done anything to mine.
Me neither.
Me neither.
Huh.
It sounds normal now, huh?
Yeah, it sounds way better.
Yep.
Okay.
Yeah.
Good. Okay, questions 5, we have information. Use the data file chapter 12, data A1 to answer the next 6 questions. Perform a paired samples t-test. Be sure that the test is group 1 minus group 2. Use a null hypothesis of 0 and alternative is not equal to 0 and a level of significance 0.10. Hold on, I want to make sure I have the right thing.
Okay. So this is just basically like the question that we did, right?
Is it?
So you have to take that. Did you guys download those
Excel.
that information onto the
Yeah.
the
Yeah.
Excel doc?
I have it.
Yeah. So basically, you just copy that and paste it into the paired sample t-test within the what is it, quantitative inference procedures.
Mm-hmm.
So confidence level or the level of significance, if it's 0.10, is that a confidence level of 0.90?
Say that again. Point.
So
Confidence.
when you've got a level of
Oh,
significance, yeah, the alpha in
yeah.
significance,
It's.
is that 0.90 when it creates the confidence level?
I think so.
Because isn't it that what that equal each other, or both of them equal 1?
Yeah.
Okay,
I'm
so
pretty
then,
sure.
yeah, that's what I thought.
Like
So-
it doesn't sound wrong. It sounds right to me.
Okay,
So I got 0.407. Is that what you guys got?
yeah, I also got 0.407 for the test statistic.
Me too.
Yeah.
Okay. And then the p-value is 0.689.
0.689. Yeah, I agree.
Okay.
Mhm.
What is the correct decision based on this evidence?
So our p-value is 0.689. Our level of significance is 0.1.
So it's larger.
So greater than, which I think greater than, if I remember correctly, is fail to reject.
Yeah, it's failed to reject. That's what I got.
Mm-hmm.
Okay, so then it's fail to reject the hypothesis.
Okay, suppose your alternative hypothesis is instead
Greater than 0.
is greater than 0. What is the correct decision based on this evidence?
Well, let's change it then. So type of test would be a greater than.
Yeah.
Our p-value is still 0.344.
So
So it's still larger than our level of significance. So what is that?
Doesn't that not change anything though?
Mm-hmm.
So we failed to reject the null hypothesis. So that means we have insufficient evidence
Mm-hmm.
that the mean of the difference is greater than 0. Is that correct?
That's what I
Yeah.
So
Yeah.
that's answer 2, right?
Yeah.
Mm-hmm.
Okay.
Okay. Then we're off to B.
All right, let me open B really quick. Okay. B.
Yeah. So this confidence level is 0.99, right?
Yeah, 0.99 is the confidence level.
Okay.
So the first question is which is greater, N or DF?
Okay, hold on. What's our? Oh, it's a not equal to.
Yeah.
Okay, hold on. Let me just put that in real quick.
Are you guys looking at the Excel on it?
Yeah.
It's got to be n.
I'm
Yeah.
looking at-
Which is greater, the sample size or the DF?
It's got to
Our
be
sample
n.
size is
Sample size is always bigger.
our sample
Well,
size.
yeah, I'm looking at it. Yeah, the sample size is like, what is there? 2 different groups and there's 21, or there's 20.
There's 22. There's 22 in each group.
There's a total of 40. Because I just highlighted in Excel. Unless I'm looking at the wrong sheet. Let me see.
Are you using B?
Yeah, I got a count of 44 on B.
Yeah.
Oh, maybe. Oh, I'm using the wrong one. Sorry, guys.
So 44 is, and what's the degrees of freedom?
I got 21.
21. So yeah, I think N is still larger, even if we're only using one group.
Yeah, because it's 22 in one group. And then 44 total.
Yeah, that's what I think. Is that
Yeah.
making sense to everybody?
Yeah.
Mm-hmm.
I just didn't hear from Jeremy, so I want to make sure he's not lost.
Yeah, no, I'm good. I'm paying attention.
Okay. And then
So-
p-value.
I got 0.001.
Yeah.
Yeah, that's what I got.
Mm-hmm.
And that'll be reject the null hypothesis.
Yeah.
Yeah, because it's less than it's less than our significance level.
Yeah, it is less than the significance level of 0.01. So,
So we decided.
And
So
then
if
the
it-
number
if it
12
went on-
is decrease.
Are you saying that's what our p-value will?
Yeah.
Yeah, it decreases because we're making it greater. So
Still reject.
those still reject, right?
Whoa.
yeah, we still reject because it's still smaller than our level of significance.
Okay, based on your response from the previous question, what conclusion do you make?
Mm,
Did our mean difference change at all?
Let me see. You mean from the 2 different groups? Is that what we're trying to look for?
For question 14,
Mm-hmm.
I think.
mm,
Well, you reject the null hypothesis.
Yeah,
So that means that we have sufficient evidence that there is a mean difference between the two groups, right?
mm-hmm.
Because
Yeah.
we do have a mean difference. There is a mean difference between the two. It's 11.955, which is,
It's the third one.
yeah, that's what I think.
It makes more. Makes sense the best out of 4. So
Yeah. Because I was looking at the first, it doesn't make as much sense. Because, yeah,
so
there it is. Because there's.
we just need to change. So the next one is going to be the greater than 0.
So the last one?
Mm-hmm.
That kind of looks weird.
Yeah, I think it's the greater than.
It is the greater than, but it just looks weird the way they put it, you know?
Yeah, so that's that's the last one, right?
Yeah.
Yeah, gotcha.
So determine 95% confidence interval for the mean difference between the 2 groups, group 1 minus group 2. Input your answers below. What is the point estimate for this 95% confidence interval? So we just need to take that information.
Isn't a 95% confidence interval give us a level of, oh, we just have to change that in here. 95.
So the Hmm? Wait. So how do we do this one? So we have the two numbers for the confidence interval, right?
Yeah, but it's asking us for a point estimate, and the point estimates. We talked about those in the last section, in the last lesson.
Yeah, I think it was in the last lesson because I remember like looking at it today, looking over the reading just right now.
Mm-hmm.
I think it was in the last.
Yeah, and it showed that point estimates were like the mean and like the sample mean, the standard deviation.
I'll pull up
So
the
I'm trying
reading
to,
this week. Right?
yeah, that would be great.
I'm gonna pull it up real quick just to get it because I can't really remember everything from last week.
Yeah, I can't either.
I barely remember stuff from this week, but
I don't blame you guys.
So for this question, are we still using the Excel for chapter 12 data B?
Yeah,
I assume so.
they haven't changed anything on it, so I'm assuming that that's the one that we're using.
yeah. Um, so you take because they are one number. You estimate parameters. So let's read it. It says the statistics above are called point estimators because they are just one number, one point on a number line that is used to estimate parameters. Parameters are generally unknown values. Think about the mean. If U is unknown, how do we know what Rx is close to? So the way that you find it,
Is that in lesson 10?
yeah, it's less than 10. So the way that you find it is just it's the I think it's I'm pretty sure it's the variance. So that's what it's showing on here.
Point estimators.
Yeah, yeah, if you're looking at it with me.
Yeah, so there's any number computed based on data. The statistics above are called point estimators because they are just one number on a line that is used to estimate a parameter. Parameters are generally unknown values. Think about the mean. If the mean is unknown, how do you know if the sample mean is close to it? Odds of probability.
I'm just trying to figure out how they find it. We can create.
Is it adding or subtracting the margin of error,
Yeah,
or that's the confidence interval, isn't it?
yeah, that's the confidence. And so, what's our confidence interval? 95%, right? Or
Yeah, 95%.
so yeah, so we have to add or subtract our margin, whatever our margin of error is. So we start with our point estimator, and we add or subtract the margin of error. So wouldn't that just be the confidence interval?
Yeah, that's the confidence interval, but they're asking us for the point estimate for the confidence interval.
Wouldn't that just be the mean then? Does that make sense?
So like the mean difference between the two groups?
Well,
Wouldn't that be 11.955?
yeah, I'm thinking it's gonna be that because the point estimator of a 95% confidence interval is gonna be the mean on both of those both of those distribution curves. Does that make sense?
Yeah. I think we're on the right track. I think it's 11.955.
Yeah.
Did you get that by doing the means? Is that what you did?
It's the mean difference. So you
Yeah.
take the two means and then you get the difference between the two, and that's the mean difference. And that's what it's asking us for, I think, because it's saying
Yeah.
on the top of it, it says determine the confidence interval for the mean difference between the two groups.
So it's 11.955.
95. That's what I think.
Yeah, that makes
You find
sense.
the number by how again? Sorry.
It's just the two means
Of group 1 and 2?
of group one and group two, and then it's the difference between the two. So the difference is already displayed on there, so it's just 11.955.
Okay.
Because so the reason why is a point estimate is just the point that you're using. And on a distribution curve of 95% confidence interval, it's going to be both of the means, because that's what 95% is based off of.
Okay.
Does that make sense?
Yeah.
Mm-hmm. So, are we on 17 then?
Mm-hmm.
Okay. I got 6.269.
How did you get that?
6.29.
269.
How did you get that, man?
I just computed the z-score, standard deviation, and the sample size, and then calculated into the margin of error.
Is that like 2 times the standard deviation divided by the square root of n? Is that the formula you use?
No.
What was the formula you use?
Formula is z-scores times standard deviation divided by square root of n. I believe.
You did it off of that one chart that you have, huh? I mean, that one Excel sheet.
Well, I just created my own space.
So my question on that though is, doesn't it already show us the standard error of the mean, which is the margin of error on the actual document, on our Excel spreadsheet?
Huh. I don't know.
What did you say that your answer was?
Mine was 6.269.
Okay. Let's see
So I don't understand why there's a difference.
I wonder, did you use a sample size of 44?
No, I put 22.
Oh, okay. Well, we can try. I'm just trying to understand that. We can try that one if you guys want to do that, and then if it doesn't work, we can.
Yeah.
What were you thinking, Tom?
What?
What were you thinking?
I don't know, because I think that Kazuya is right with the process of figuring that out. Like, that's definitely the way to figure it out. But I'm hesitant.
Yeah, 17, I got it wrong. I just submitted it.
Oh.
And we got the 15 wrong.
We got 15 wrong as well?
Yep. And also number 4.
But the rest of the stuff is right?
Yep, 4, 15, and 9.
What's question
4, 15, and 17. And by the way, the 18 is 5.303.
Wait, what was that?
Number 18 is 5.303. And then 19 is 18.607.
Did you get that just from the actual data? So.
Oh, you got it off of your thing that you plug in, right?
Yep.
You need to make me one of those.
18.607.
So it was 17. Have we figured that out?
So I think that it would be what it says in the actual document, where it says 3.199, if it's not the one that Kazuya got.
You think for number 17 is...
Yeah, I might have used the wrong number or something.
I'll submit it.
Okay.
Should we go through the other questions we got wrong first?
Yeah, let's try and go through that. So as we've seen, the p-value, I'm on question 15 because...
Okay.
So what did you put for 17? 3.199?
199.
199. Okay.
So question 15, as we've seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? So if it's not that one, even though we worked through everything, would it depend on the problem then?
Yeah. I would think so. Should we go for that one for now?
Because it also depends on your p-value is also, no. Sorry. Yeah, let's try. I'm going to put down not enough information depends on the problem. And then if I
Okay.
get that wrong, we can go back on that. What were the other questions that we got wrong, Kazuya?
Hold on. 4, 15, and 17,
17, okay.
I think. Yeah.
We already redid 17, right?
Yeah.
And we already redid 15, right?
Yeah.
Now we
The
put a 4.
yeah.
Probability of obtaining a test statistic greater than is 0.040403.
Wouldn't we? Oh, man. You plug that into the pellet, right? The point.
Yeah, I put that in the probability applet,
So what do
but maybe I did that wrong. Hold on.
Here, let me look at it too. I'm gonna.
Because I was looking in the homework or the textbook, and they said that the way to do it, let me just make sure I have the right information so I'm not leaving us astray.
So what did we decide on 17? Just the difference of the standard error of the mean?
Yeah, because I'm pretty sure that's the margin of error.
Mm-hmm. All
Let me
right.
just check this.
So we only have number 4. Um,
And what did you get for that answer? What did we get for that answer again? Number
For
4.
17.
Did you? So Tom, when you did it, what did you put into the z-score?
What?
What did you put into the z-score on that one? On number 4.
I put it in the test. Hold on. Horizontal axis. I think I put in 2 because this says the test statistic t is labeled on the horizontal axis. The p-value is the area to the left of t under the curve. So maybe I just did that wrong.
0.977. Yeah, because that's what it gives us.
So p-value is equal to
Come in, please.
maybe it's 0.0228.
Yeah. What are you doing? No, because you have to get the parts in IF. Okay, let's see. Kazuya, did you plug in the numbers to your thing?
The number 4.
Yeah, to find the p-value.
I'm not quite sure we can use the Excel.
Yeah, because do they not have enough information right there?
Honestly, I can't. I don't know.
We got and I don't even know what. I can't remember what all these numbers mean.
Is zero.
Let me see.
This is hard.
See what numbers we have. What did we say we got for the z-score on that again? You said 2? Then that wasn't right.
That's the test statistic.
Oh, that's.
And yeah, it's right in there. So maybe we have to figure out the z-score first.
Z-score is 2.051 if we use the normal probability applet.
Let's see. So you said if we use the normal applet, you said it's 2.051, right? Yeah, that still comes out to 0.979 or 9.980. I don't know if that's right.
Hey, wait, what if it's... So it's asking us what's the probability, or the probability of getting a test statistic greater than Jordan's test statistic is 0.0403. So with that, what if you plugged that in as the probability area on top, and then you highlighted everything to the right of that z-score? Wouldn't that give us that probability value?
Could try it.
So you said highlight everything to the right of that?
Yeah, so I plugged in on the top, if you guys want to do this with me, I plugged in 0.0403. And then, so let me just do this again. think you're supposed to start off by highlighting both tails. Oh no, because I can't remember. Anyway, when I did that, it gives me the same z-score as what Kazuya said, and then if you unhighlight the left tail, I got 0.0201.
Yeah,
that's
I got the same thing.
Does that sound right, or is that like way off?
I think it's worth a shot.
So Leslie, did you want to put that in there and see if we got the right answer for that one?
So put in that number that we just discussed right now, 0.021.
2-0.
Because is it asking greater than then?
Yeah, it's asking a probability of obtaining a test statistic greater than Jordan's.
Okay, that one makes more sense. 0.0221.
0. Yeah, but don't put in the 1 because it's just 3 decimal places.
So 0.020 then?
Yep.
Yeah.
Okay, let me try. It's still not right.
Mm,
Did we get the other answers right?
Yeah, so 17 is not right still.
What?
Everything else is right. So we got 18 out of 20 right now. It's at a 90%.
90%. I don't know how to get that margin of error. Man.
nice.
Yeah. So I was just looking at margin of error.
Level of significance on that one. Is that a 0.05?
Yeah, I think so.
Hey, let me just make sure I put in. So what did we get for 17 to make sure I put it in right?
3.199.
Okay, yeah, that's what I put in.
Yeah.
Mm,
Oh. Hold on.
so it should be right. though.
I'm going to see if I can do it again manually.
Because so margin of error. Let me see. I want to recalculate that real quick. So what are the numbers we're using for this one?
For number 4?
For number 17, because I'm doing that one right now.
Margin of error. Hold on.
Like,
Okay, I'm going to go back to the regular page in order to find it.
So margin of error. Let me. Let's see. So 1.96. Is our standard deviation known in this equation?
See, that's what I'm trying to figure out. Like, where's the information?
I think our standard deviation is
Well, it's asking for the difference, so I just put in 15.003. And I got the,
95% confidence interval.
Where'd you get that number though from?
the Excel.
Okay. So that'd be 1.96. Close. So z-score or that times standard deviation.
For 17, have we tried 11.955? Was that our first answer?
11.995 is the mean. So I don't think that would be, because it's asking for the standard, the margin of error.
Sorry, I did it.
It's okay.
Would it, I mean, actually, no, I was reading the wrong number. Would it be 6.652?
What'd you say?
6.652?
How'd you get that? 6.692.
652. I don't know. I was just isn't margin of error determining how far away you go for your lower and your upper bound? Isn't that right?
Yeah, so
Thank you, Master.
see if I got the same one. that you got.
What I did is I looked at our upper bound and I did 18.607 minus 5.303. And I got 13.304, but then I divided that by 2. And I got 6.652. I don't know if that's right. It's just worth a shot.
Why'd you divide it by 2 though?
Just to get the middle in between because so like it's, I don't know, to give, it was the point estimated for the 95%. I don't know. I'm just kind of playing around.
Because the formula is like,
The formula is the z times the standard deviation divided by the square root of n.
yeah, that's what it is.
Yeah.
So my question is on this, because we know the standard deviation, wouldn't we use 1.96 on it instead of 2? Because 1.96 is the actual, what is it called? Confidence interval thing that we would multiply by. So when I do it, I got 1.96 times parentheses 15.003 divided by 22, which is square rooted.
Yeah, I did that,
I got 6.269.
which is wrong.
That's the one that we started off with.
Yeah, that's the one that I submitted as.
What is our n?
22. It should be.
It's 22?
Yeah.
So let me see. And then what is our what is that? I forget what that little freaking circle thing is. That our standard deviation?
Yeah.
So what's our standard deviation?
For Zuya, I think it's 15.003 because it's the difference between the two.
15.002, you said?
003.
003? Okay.
So,
I need my other calculator for this one.
Are we just rounding it right or wrong? I mean, it doesn't say anything about the rounding part.
Oh.
Oh.
I'll just share with you. We'll just be cheering. Yeah, I just shared it. Well, no, man. I have to. Come on. Oh! Okay, sorry guys. I gotta go grab my other calculator. Did you guys figure it out though?
Hey, I just submitted my, and the answer that I said, I got it right.
What is
What
it?
was it?
0.652.
Yeah, 6.652.
Holy cow, that's awesome. Way to go.
So this is what I like. Let me go more into detail. So the lower bound is 5.303, and the upper bound is 18.607. So somewhere in between there, the answer has to be in there. So I added the 5.303 and the 18.607, and that became a total of 13.307. Now we want to find the middle of that, and so that's why I divided it by 2, and I got 6.652.
Got
Did
it.
you get
That's awesome.
100%?
No.
Probably not because we still don't have question 4 answered correctly.
Yeah, question 4 is still around.
What did we put for the last one for question 4?
It was 0.020.
Okay, so like 3 out, then 3 out.
Those fellow. Mata始まるよ。
So what was our test statistic?
Oh.
So for 17, our answer was 6.652, right?
Yeah.
Ah, dang it. Okay. All right. Well, hey guys, I gotta go take care of my kids. So see you on Wednesday then.
Later.
See ya.
Yep.
So we're just trying to figure out, guys, we're trying to figure out number 4 right now.
Yeah. Yep.
Idea what to do.
All we have is the test statistic, though. Or do
Yeah.
we have?
All we have right now is a test statistic and a probability. Wait, hold on. Trying to figure this out. Okay, so what's the question?
So our test statistic is 0.0403. 0.0403. What is DF? Oh, hold on. Oh, I have no idea. Do we have degrees of freedom on this or no?
Not on this question.
Hmm. So all we have is this information is our test statistic, and then you said our probability, right?
Oh, but we do have all you have to do is take your test statistic and subtract the sample size from it, and that'll give you how many degrees of freedom.
Degrees of freedom it is.
Yeah, hold on. So 9 minus 1. So we have 8 degrees of freedom on this.
So it's just 8?
Well, that's giving us the degrees of freedom. I'm trying to figure out.
So, we don't have really level of significance, and we don't know if it's a one or two-tailed hypothesis, huh?
Well, it should be a right-tailed hypothesis because it's asking us. Like the original one's a two-test hypothesis,
But this one's a one-tailed, right?
but this one I think is a right-tailed because it's asking the probability or telling us the probability of obtaining a test statistic greater than our test is.
So it would be right-tailed or one-tailed, right?
Yeah.
And our significance would be like 95, right? Assume.
Yeah, we would assume that.
I don't know.
I actually have to go pretty soon. I have another meeting that I have to get to.
Yeah, I'm gonna have to go
I might
soon too.
So how many?
Well,
What did we get before? What was our answer?
We last answered 0.020.
Yeah, I don't even know, man. I got so I just submitted it because I knew you guys had to go. I used this formula and I got 0.484 and it was wrong.
Man.
So that's not the right answer. I'm done out of tries. But you'll still get a 95%. Maybe you can figure it out tomorrow.
Yeah.
Save all your
Yeah.
I'm gonna take off the guys that don't have any more tries, so
Yeah.
All right.
All right. See you,
Yeah.
man.
Yeah, we'll see you guys later.
Yeah.
okay. Catch y'all later.